Carrying and handling liquefied gas cargo on board ships possess significant potential hazards to the crew and the environment. Each person working on a gas carrier and terminal ashore needs to understand the risks involved, obtain the necessary training, and take all the needed precautions. There is always a possibility of the presence of gas in the atmosphere, particularly during loading and discharging of liquefied gases, when the ship is gassing up or being gas freed, when a pipeline or cargo pump is opened up for maintenance, in compressor rooms, within ballast tanks and void spaces and double bottom tanks adjacent to cargo tanks. LNG or liquefied natural gas, as the name suggests, is the liquid form of natural gas stored at controlled temperature. LNG carriers are specialized ships that transport LNG at its atmospheric pressure boiling point of approximately -162 degrees Celsius. Before we dive further into LNG tank construction and cargo operations, please do subscribe to our YouTube channel and press the bell icon for further updates. Most cargo tanks are constructed from stainless steel, which is a material that retains its flexibility and strength characteristics over the temperature range of -180 degrees Celsius to 50 degrees Celsius. There are different types of LNG cargo tanks, and we will discuss two important types. Membrane. The tank consists of a very thin layer called membranes of a special steel, invar. It minimally expands and contracts, and the layer of steel is about 1 mm thick. There is a second membrane providing a secondary barrier. The space between these two layers has a plywood box filled with perlite insulation to support and insulate the tanks. Usually, these spaces are supplied with positive pressure nitrogen. Moss tank. The Moss system uses spherical aluminum tanks that have a working pressure of 22 kPa or 3.2 psi, which can be increased in case needed. They are self-supporting and are secured around the equatorial ring. All pipes and equipment are carried in a central column. There is a drip tray provided at the bottom to catch any leakages and avoid damage to the hull. Ballast is carried below and alongside the cargo hold. Cargo operation preparation. Usually shore terminal and LNG tanker loading systems are linked by loading arms or by pipes. All the flange connection details are checked and have valid certificates. LNG is a cryogenic substance and its main component is methane. It gasifies violently when directly introduced into a cargo tank at ambient temperature, rapidly increasing the internal pressure of the cargo tank and making the atmosphere into a flammable condition. Inerting of cargo tanks. Before introducing cargo into the tanks, the moisture content and oxygen content in the tanks shall be reduced simultaneously. Cargo tanks filled with air are dried and inerted with inert gas supplied from the inert gas generator on board. Inert gas is led into the bottom of the cargo tank through the liquid filling line, and displaced air is vented to the atmosphere through the vapor line and the vent mast. The dew point and oxygen content are periodically measured by a portable instrument at the sampling lines in the cargo tank dome. Inerting of annular space for Moss type vessels. The space between the surface of a cargo tank and insulation is called annular space. Annular space is inserted with nitrogen gas and continuously supplied from N2 generator through the N2 bleed line. For membrane type vessels, the space between the primary and the secondary barrier is called inter-barrier spaces or IBS. The space between the secondary barrier and the inner hull is called insulation spaces or IS. In normal operation, IBS and IS shall be purged with nitrogen. During cargo loading, as normal procedure, IBS pressure is maintained at or below cargo tank pressure and IS pressure is maintained at or above the IBS pressure. Gassing up. If the purging has been done with inert gas, the cargo tanks have to be gassed up and cooled down when the vessel arrives at the loading terminal. This is because inert gas contains about 14% carbon dioxide, which will freeze at around -60 degrees Celsius and produce a white powder which can block valves, filters, and nozzles. During gassing up, the inert gas in the cargo tanks is replaced with warm LNG vapor. This is done to remove carbon dioxide and to complete drying of the tanks. Initial cool down. Cool down is an operation to pre-cool cargo tanks and lines required before taking on cryogenic LNG. Cargo tank cool down is carried out by spraying LNG through the spray nozzles of each cargo tank using LNG received from the shore terminal. Before LNG can be introduced into the cargo system of an LNG vessel, the system, and in particular the cargo tanks, have to be cooled down to a temperature close to that of LNG which is to be loaded. Air purge of loading arms. After the connection of loading arms, air should be purged from the loading arms and the tips of manifold pipes. Loading arms cool down. The cool down of the loading arms is performed from shore side by use of a small capacity pump. At a discharge port, the arms are cooled down by sending in LNG by ship's spray pump. Loading operation. LNG is loaded via the loading manifolds to the liquid header and then to each tank filling line. The boil off and displaced vapor leaves each tank via the vapor suction to the vapor header. The vapor is initially free-flowed to shore via vapor crossover manifold, and as tank pressure rises, one compressor is brought into operation to increase the gas flow to the shore and limit the vapor main and cargo tank pressure. As the loading rate increases, it is important to monitor the tank pressures and to start one HD compressor. If the compressors are unable to cope with the volume of boil off and displaced gas, it will be necessary to reduce the loading rate. It is important to maintain a water curtain below the loading pipes to avoid hull structure damage if there is any cargo leakage. The ice also needs to be washed off from LNG loading pipes. Bulk loading. When all lines and valves are fully cooled, the vessel can commence ramping up the loading rate in the sequence agreed with the terminal. Deballasting should be commenced in accordance with the cargo plan. BOG and reliquefaction. The boil of gases during the loading operation is cooled down. This is done by using a reliquefaction plant. BOG is removed from the cargo tanks by means of a two-stage centrifugal compressor. The BOG is cooled and condensed to LNG in cryogenic heat exchanger or cold box, which liquefies the BOG and returns the LNG back to the cargo tanks. If you like this video, please subscribe to our YouTube channel and press the bell icon.